What attracts the attention of the world? What tops the prosperous peak? Who leads the trend of energy-saving building glass? China Southern Glass Holding Group Company Limited. Founded in 1984, CSG became the first listed company in the industry in 1992. From the first introduction of foreign advanced technologies to the possession of internationally leading R&D level. From a leader of the industry in China to a global famous brand. With over 30 years of persistent pursuit, CSG has set up many milestones in China's building glass industry. With more than 20 subsidiaries and 5 top building glass production bases in China, CSG has established a complete production chain of quartz mining, float glass production, low-E energy-saving glass processing, and its capacity tops the world. CSG is leading the new trend of building glass in China and even in the world. People turn sites to high-rise buildings due to the high-speed global economic development, urban population explosion, and land scarcity. Glass as the essential material of high-rise buildings, its safety and energy efficiency have been focused on by society. As the industry leader, CSG has been continuously developing a series of safer, more energy efficient, more comfortable, and more beautiful products with its strong R&D capability, which widely meets the fast-growing building demands. CSG now has 14 of the world's most advanced glass coating lines, with an annual low-E glass capacity of more than 50 million square meters. It launched single silver and double silver low-E glass production in 1997 and 1998, and developed triple silver low-E glass in 2007. The triple silver low-E glass started to be applied on overseas projects in 2009. And CSG is the first China company publicly releasing technical data of triple silver glass products in the world in 2010. The low-E glass products of CSG are featured by outstanding performance and aesthetic effect. The triple silver low-E glass can screen more than 97% solar infrared radiation, which most effectively reduces the cooling load of air conditioning system, cuts the investment of air conditioning equipment, reduces building operational cost, and improves the indoor comfortness. Relying on independent R&D, CSG achieves technical breakthrough. Successfully and firstly in the world, developed various triple silver low-E glass series of a rainbow of colors and brightness to meet the requirement of various building design concepts and styles, and the products have been widely used in numerous landmark buildings in the world.
哎，可以了。
to meet the growing demand of building glass market. CSG, equipped with the most sufficient coating lines, insulation glass production lines, laminated glass production lines, heat soak furnaces, and a complete set of cutting, edging, tempering, and ceramic fret equipment, as well as special jumbo size glass processing and bending machinery. Besides, as the industry leader, CSG has developed a variety of new products to meet the potential demand of customers. Interior surface low-E coating, anti-reflective glass, electrically heated glass, micro insulation glass, colorful glass, mirror display glass. In addition to the products, CSG also provides perfect and comprehensive services with the technical support of senior industry experts, worldwide direct sales network, strong storage capacity and logistics transportation. CSG provides whole process tracing and sincere project services. Buildings like solidified poems and vivid paintings, turning buildings into art to show city classics, decorate the world, and realize harmonious development of building and city with our products. Energy efficient and comfort, we make quality goods. With safety and beauty, we set up a leading brand. Pilot of energy-saving building glass, CSG Holding Company Limited.
Hello, hello. Is everybody here? So, can everybody hear me? All right. Okay. So here we go. Welcome back to Glasstech Asia X PERAFI webinar 6, Safety in Glass and Facade Application. Glass is the most preferred facade element in modern architectural design. Despite the ease of installation and maintenance, understanding the risks in glass remains a critical factor to ensure safety. My name is Gan Pei Yap from VJF Fire Rated Glass Systems. I'm delighted to be your moderator and host for today. First, I'd like to applaud Glasstech Asia and PERAFI for putting this platform and bringing together the network of glass and facade professionals. For those who are unfamiliar with Glasstech Asia, it is an annual rotating exhibition that focuses on all things glass. Glasstech Asia is Southeast Asia's leading BAO trade fair and a powerful network for the glass industry. In addition, the trade event will be held in conjunction with Fenestration Asia, a showcase for windows, doors, and facade innovations. Participants will have the opportunity to meet leading regional buyers from ASEAN's major markets and have purposeful networking. And the good news is that Glasstech Asia will return to Singapore in 2022 at Marina Bay Sands Expo and Convention Center. And this is organized by MMR Asia and Messe Munich. So please mark down your calendar for October 26 to 28, and we look forward to see you there. I would also like to acknowledge PERAFI, Indonesian Facade Association, an organization dedicated to improve quality of building facade industry and fostering sustainable and equitable business relationship to drive growth of facade industry through advancements in technology and standards. Throughout this session, please feel free to enter your questions in the Q&A chat box. We will cover them during our Q&A sessions. For unanswered questions, we will link you up with the speakers after the webinar. Our program today will be around 2 hours, and we have 5 veteran speakers with diverse and rich expertise. At the end of this presentation, we will have a discussion session where we have a meaningful discussion with our speakers. Before we start, I would like to thank our sponsors, CSG and Curare Asia Pacific. Please allow me to introduce CSG. CSG is the first and largest low-E glass manufacturer in China with 8 low-E glass production bases. CSG started low-E glass production back in 1997 and has its own R&D center for low-E coating and coating equipment, independently developed numerous low-E coating, including single, double, and triple silver low-E, as well as temperable low-E glass products, and design and assemble its own coating lines. In all major cities in China, most of the high-rise buildings are decorated with CSG's low-E glass. CSG also supplied various low-E glass products for numerous projects in countries and regions, including USA, Canada, New Zealand, Japan, Iceland, Russia, Indonesia, Singapore, Malaysia, India, Qatar, Kuwait, UAE, and many more. Next, I would like to introduce Curare. Curare is the leading manufacturer for PVB and advanced interlayer for laminated glass for architectural and automotive applications under the master brand Trosifor. It has the broadest product portfolio to offer the best matching interlayer solutions for a wide range of applications such as safety, security, structural, acoustics, decorative, and photovoltaics. Curare's advanced interlayers such as Sentry Glass, Spoil Shield are highly innovative products that have no match in the industry. To get more information, you could either contact Curare directly or visit them at Glasstech Asia, stand H2. Without further ado, now I would like to welcome our very first speaker, Nisha Gopal, Head of Facade Integrated Solution Europe at Lendlease. I'll give a short intro on Nisha first. So she has a MSc in Facade Engineering. Nisha started her career as an architect, Following a role as a project architect at EPR Architects, she then specialized in facade engineering. Nisha is active within the industry as a member of CWCT Technical Committee and a board member of the Society of Facade Engineering. Nisha also supports initiatives to expand diversity in construction, including taking part as an ambassador for women in construction and as a judge for the Women in Construction Engineering Awards. Today, Nisha will be sharing with us about the safety requirements and impacts of realistic glass. Nisha, whenever you're ready.
Thank you very much for that introduction, Pei. So now the wonders of technology, I shall start sharing my screen and hope it works. There we go. Is that sharing?
Yep, we can see.
Wonderful. So I will start. I'm just going to give you a very short introduction to Lend-Lease, who I joined 2 years ago. I'm now working in the construction and development world, which is really interesting with my background. So I'm sure a lot of you have heard about Lend-Lease. So we're creating communities and places which concentrate very much on social, environmental, and economic values. It's a very exciting business. We are global, so we cover from the States, Europe, the East, and Australia. I'm very much focused in Europe, but obviously do hear what's happening in the rest of the business. And we are a huge global business, which is very exciting. I just want to say we don't just work as contractors, we are developers and also investors. So our business is incredibly diverse. And as you saw from our previous slide, our pipeline is really huge. So really important that we understand materials, etc. Something we're really concentrating on now, and I know this is different across all the regions in the world, but something we're really concentrating on in Europe at the moment is our mission zero, trying to meet net zero carbon by 2025 within our business, and absolute carbon zero by 2040, which is proving to be a huge challenge. Anyway, now I'd very much like to share with you my presentation on realistic glass. Glass is fascinating. Pei, as you mentioned before, it's challenging. It's used throughout building industry. And as an architect and then facade engineer, I realized that the material is actually far more complex. And my dissertation I did when I was doing the master's in facade engineering was actually on visual inconsistencies of glass. So anyway, I'm now going to have a short presentation. It's a bit of a sort of glass horror stories, really, some of the slides I'm going to show you. So anyway, starting on, so something that fascinated me as an architect, you can see the building on the left is a CGI created by an architect for their vision of the building. And on the right, you can see how actually very different it looks. So this made me really start looking at why is glass so different to the way we want it to look. This is another project I worked on the left at Lend-Lease, was the CGI created by Richard Rogers Architects, and on the right you can see actually the building looks quite different. So coming on to safety glass, this is so important. At the end of the day, whatever application we're using the glass, we have to look at the safety of its use. So certainly in UK and Europe, we tend to go to Syria. They have a document which you can download, and we ask all of our consultants to provide a glass risk assessment. So this is the architect and the facade consultant. Now, what you need to do is assess the likelihood of occurrence of injury versus the severity of the injury. And this we look at with every single type of glass on a project. If it's in the red zone, the glass has to be changed. If it's in the amber zone, we look at other ways where we can actually improve the safety of glass. And the green is a tolerable risk. I'm not going to go into too much of this. I know one of the other presenters is doing more on safety glass, but just to let you know, that's how we assess it, certainly in our business. Again, looking at the different types of glass: annealed, heat strengthened, and toughened. annealed and heat strengthened break very similarly into large shards, and we know that can be very dangerous if it breaks and falls. Toughened, we know it breaks into smaller pieces. So from our point of view, we look at either laminated glass or fully toughened glass is currently under the British standard is a safety glass. Now, something as a business, and I've certainly seen it changing, the use of toughened glass really does have its uses, but there are also some issues with toughened glass in the way it breaks. We know it breaks safely into small pieces. However, if it's laminated with, say, a PVB interlayer, it can actually turn into almost like a blanket, as you can see from here. So really important that we think about how that glass is supported if we're using it in that way. I'm going to play you a very short video, and this is something which is very important because people say fully toughened glass breaks into small pieces. Actually, you'll see from this that sheet fell out, it had broken, and it wasn't until it hit the ground that it really broke into small pieces. And that's something that we're seeing certainly in the UK, and I wanted to share that with you. This is actually taken in the Middle East, but it's quite a famous video clip. I just find it's pretty crazy, and that, as I say in the slide, is a near miss for that guy. So what I'd like to touch on now is glass quality issues, and this presentation is going to show you some of the issues we have when we're specifying safety glass and what that can actually mean for the visual impact on that glass. So this is a project I worked on some time ago. It's in London, and it had a series of toughened glass on it. And as you can see very distinctly, this was curved glass that was formed with rollers, hot rolled glass, and this has quite distinctive roller wave. And of course, with bricks in the background, sorry, excuse me, you can really see the distortion. This is another project where, again, tempering caused edge distortion of the glass. And again, if you've got something you can see behind the glass, then you tend to pick this up. Again, we wouldn't have known there was edge distortion on this particular piece of glass, except for the fact there was a crane in the background. So these are, I find these fascinating. And actually with this particular project, because we had brickwork, etc., we had very much square pieces of glass. We understood from the manufacturing process, this was actually causing some of the problems with the edge distortion. I think we've also got to be very mindful that sometimes we can look too closely at the glass, but in this case, because there was, being UK, we used a lot of brickwork here, it very much picked up the distortion. And in fact, we ended up having to change some of the glass. Again, you can see the backdrop here picks up the distortion. Now, this is quite an interesting phenomena called dishing. And this is when you temper the glass and then it doesn't cool regularly across the glass. You tend to get a crease in the middle of the glass. And we had several of these, and they really can be quite distinct. So quite an interesting phenomenon. I first only came across this about a couple of years before this. And again, when you've got the backdrop, you can really see how severe the dishing can be. Now, I think it's really important, having worked in consultancy and now as a client, it's really important to understand what visual aspects you should be looking at when you're inspecting glass, and agree those aspects and very early on in the project. Now, we know that as you change viewing angles, that the distortions can become quite different. And this again is a project where, as you can see, as you increase the angle, the viewing distortions got quite severe. Now, this is caused by something called multi-layer lensing effect. And as you can see from here on this side, it was actually quite disturbing if you were in that building. It was a residential building, and you wouldn't really want to be seeing that from your sofa, for example. So in fact, unfortunately, on this project, much of the glass had to be changed. I'm going to quickly explain what caused this. So we already had a very tight roller wave specification on this. And what we realized was actually when you laminate toughened glass, because it's got the roller wave in it, if the peaks and troughs don't match each other, they actually cause little mini lenses in between. What we ended up agreeing with the manufacturer was to actually completely reduce the roller wave on the glass, which again caused a lot of wastage. And then we inspected every single piece of glass that was manufactured at the factory before it was shipped to the UK. But again, a lot of these phenomena are coming out now because we're changing our specification of glass from monolithic to laminated. So really to just be aware of those phenomena. And here you can see that we did actually have some failures at the factory as well that had to, were not used on the project. I want to touch on some of the other issues that we have with safety glass. So with laminated glass, you can get bubbling. This is if you may not recognize it from this photo, but this is actually the BBC's headquarters in London at Portland Place, and it had some very special laminated glass. And again, for people who are there as designers, really think about how you're specifying this. The glass was so special, it was 2 pieces of laminated glass, each had a different frit on it, and they had to be laminated together with just a plus or minus 1 millimeter tolerance. And this was all done by hand. And some of the sheets were 2 by 3 meters. So you can imagine that was very challenging. The patterns then had to line up. And here you can see that we noted that they'd actually put a piece of glass in upside down because the lines didn't run through. So that was quite an interesting phenomenon there. But again, as designers, I'd say really think about what you're asking your manufacturer to have to do. Another issue we can have, if you can see this, is we've got a stepped edge here with the laminated glass. And if this ends up being the supporting edge of the glass, you can get 1 ply of the glass taking all the loads, and that can cause failure. So again, think about your tolerances, inspecting glass in the factory before it comes to the fabricator or to site is so important. I'd like to also touch on delamination. I also must thank my ex-colleagues from Meinhardt who had kindly sent me some of these images for a presentation I did a little while back. That really fascinating. You can see how bad some of the delamination has become in some of these. And in this particular one, how the moisture ingress has really made the glass look terrible. So in a lot of these cases, the glass may not fail, but it looks awful. In other instances, in this case, we had a structural glass roof, structural glass fins, and the glass started to delaminate. And what was really difficult with this was the design of the glass had been that both panes had to take the loads. And in fact, we couldn't prove, the contractor couldn't prove that actually one pane of the glass, if it did delaminate, could take the loads. And they ended up having to remediate the roof. We all know about nickel sulfide, so I'll just touch on this, but something quite interesting. So again, there is very much here, we heat soak test the glass to try and mitigate that. And here you can see one of the butterfly, the nickel sulfide inclusion. What was interesting, one project I saw fairly recently, which again appeared to be nickel sulfide, we had a look at the inclusion. In fact, it wasn't nickel sulfide, it was aluminium. An aluminium piece had got into the glass and caused the glass to fail when it had been on the building after about 3 years. So interestingly enough, we wonder how many failures are actually nickel sulfide or something else. This was an interesting one from another colleague who apparently it was an inclusion, and in fact the glass had been heat soak tested. So although it does really absolutely reduce the chance, there apparently you can still get some failures. So just be aware. So if we're trying to go to an annealed solution, we must be very aware of thermal stress. And this was an office building in London where they'd used laminated annealed glass. And although the office tenants had been told to use light coloured blinds and not to put furniture against the glass, they did so. And as you can see, there was some very severe thermal stress cracks, and they had about a 20% failure on this project of the glass. So we started doing some investigating, because we thought in some cases, is it purely just the fact they put in furniture? And actually what we found is, you can see the edges of the glass when we deglazed were very poorly finished. They hadn't been ground or polished. And we know this helped contribute towards the failures. So again, a lot of this glass had to be remediated. I'd like to talk again back to realistic glass. So this was a fantastic project I worked on with Zaha Hadid Architects. Sadly, it wasn't built, but I just again like to share the architect's vision. It's an amazing gold building, and how do you achieve that in glass? The client then got the CGI and said to me in a meeting, Nisha, I want the building to look like sand dunes at sunset. I must say, I don't know any RAL colour that is actually sand dune coloured. We basically had ended up going literally around the world trying to find gold coloured glass, and we found 2 types of glass. And then we started to do the slump testing, or the slump curvature of it. And actually what you found was the colour of the glass started to change dramatically with the curving of the glass. Now, the project was never built, and I do wonder if we would have actually achieved the vision because of the issues with the discoloration of the glass. So this was another project, which again, the visual on the left, this is in Dubai, and this is it built. I worked on it very early on. And what we had tried to do is to look at as much of the glass being cold bent as possible, so that you didn't get those visual distortions. Unfortunately, in the end, a lot of it was cold bent, but some of it, where you can see the lighter blue, had to be slump formed and then chemically toughened, and actually you ended up with quite a different color. So it's so important to get testing of your glass done before. This is not a great photo, I'm afraid, but again, showing glass that's all supposed to have the same colored coatings. The one on the left is curved. The one on the middle one is supposed to have been tempered, used the same coating as the curved, which was temperable coating, but wasn't tempered. And the one on the right has got yet a different coating. So again, not great from a visual point of view. This again was courtesy of one of my colleagues at Meinhardt, who I believe is on the call today. So this was quite an interesting one, where again, the coatings were supposed to be the same for the flat and the curve. They were supposed to give the same visual appearance, but didn't. What I would say from this is, it is so important to get sampling done of any glass that is in any way different. Really, really important. One I just wanted to touch on again is visual defects due to the tempering, is anisotropy, which we see both in flat and curved glass. And here's another example. One I wanted to also pick up is on these white lines, is what we call white haze, where the rollers pick up and cause issues with that. I just wanted to cover this. This is very much, it's so important that we think about how we view the glass. So highly reflective glass, and I know in certain parts of Asia where I'd worked, there was a limit on how much reflection your glass could show. And I think this is just to give you some examples of how severe it can be, and how it can then pick up distortions due to roller wave if the glass is tempered. Again, it's very important understanding reflectance and light. So this is when I was working at Meinhardt, this was a building right next door to our office. And I used to look at it every morning, and in the mornings it looked fine. By lunchtime, the curved glass was looking quite different to the flat. And when it was really sunny, you can see it was quite different. So I just wanted to show you, it's about understanding glass during the whole day, during all the different seasons, how it might change in look. This is one that some of you may know. It's the walkie-talkie in London. And I was walking back from a meeting, and it was a really sunny day, and you can just see how distinct the distortion is due to the pillowing. And then a week later, we had as a usual grey day in London, and actually it looks fine. So again, just thinking about how your building is going to look throughout its day and the seasons. Again, very mirrored glass will pick up distortions and pillowing. And again, just some of my pictures I've collected over the years showing how different coloured glass, different mirror effects give you some distortions. You're quite often not going to get maybe what you're expecting. So on that note, I would just a few thoughts on how we can improve quality. It's really important to be realistic about your expectations. Originally, when I started doing the presentation similar to this, I used to call it visual defects, but actually it's about being realistic in what the glass can do. Do a risk assessment, understand the safety of the glass, and ensure that it meets your cost plan. In respect to procurement and installation, so important on sampling. So often sampling and testing, we'll say, oh, maybe we shouldn't spend the money on it, it'll be fine. And actually then you find it gets to site and it's not what you want. Ensure you have benchmarking, make sure the glass is correctly stored, and ensure quality control during installation. And also make sure your facades are protected during the construction. So one thing I would just like to touch on, and this is very close to all our hearts across the world now, is sustainability considerations and how we really should be thinking in the long term, how we are now going to think about recycling glass. And that concludes my presentation. Thank you.
Thank you, Nisha.
And I'll stop sharing now, shall I? Yeah.
It was certainly interesting to hear Nisha share her experience from an architect's perspective. And I'm sure the common problems she showed us, we are able to learn and avoid the same mistakes. We can take perhaps one question. There's one comment from Slava Sharin. He said, it's more of a comment than a question. He said, you can achieve good gold color by laminating some architectural soft-coated glass with a silver layer, single silver basically coating to PVB.
Thank you.
Yeah.
I think it was really interesting, because actually what I didn't explain about that project was that particular glass was monolithic, as you say, and so we went for a pyrolytic coating, a hard coating, to try and achieve that rather than laminating. But no, that's very interesting to know. At the time, we were trying all sorts of different products. But no, thank you for that comment.
Okay. I think there's no other questions. Oh, there's one more.
There's one about, are there facilities that recycle glass? It's quite interesting. Shall I answer that, Pei?
Yes, please.
Yeah. So there are a lot of people, a couple of the big glass companies are currently looking at ways to recycle. And yes, you can recycle glass. And obviously there are offcuts from the factories themselves. There's a lot of work being done currently. And in fact, the SFE's AGM that's coming up very soon, the lady who's speaking at that, Rebecca, is doing a PhD on recycling of materials, and she's been doing a lot of testing on recycling. So yes, it is there, and there are methods out there that are being rolled out now, and I think that's a very important thing. The difficulty is obviously delaminating the glass and being able to use it. And is it advisable to combine annealed glass and tempered glass in lamination? Generally, try not to laminate two different types of glass together, is what I'd say. Thank you. Thank you. I think that's it.
Okay, let's move on. And if there are any more further questions, Nisha will still be here and she will take other questions at the end of all the presentation. So next, we will examine safety of silicon bonded facade. I'm pleased to introduce our next two speakers from Dow, Gerald Bautista and Valerie Hayes. So Gerald is an associate TS&D scientist in Dow for their high-performance building market covering the Southeast Asia region. With almost 15 years experience in the built environment, he provides technical, application, and consulting expertise to stakeholders in curtain wall and construction industry. Valerie Hayes is Global Facade Engineering and Architectural Design Engineer for high-performance building at Dow Silicon. In her role, she provides technical service to construction design community, including facade system manufacturers, architects, and engineers. Without further delay, I pass over to our speakers from Dow.
Let me just unmute myself and just want to make sure that we are heard okay.
Yeah.
All right.
Good.
All right. Thank you. Thank you very much for that intro. I just want to say hi to Architect Veronica because I know he's in the chat right now. He's an architect from the Philippines. I think we just go straight to our presentation, and please do let me know. Okay, let me share my screen first. All right. Let's see if technology can be my friend today. There you go. The screen is okay? All right. Okay, I think we go straight to our presentation. First of all, thank you very much for the attendees. My name is Gerald Bautista, and together with Ms. Valerie, I'm based in Singapore. Valerie is based in Belgium, so she's doing this now right from Brussels, Belgium, and we are from Dow. And I think some of you may be familiar with our company, and we are mostly involved in your silicone structural glazing and your weather seals for your facade. So today we'll be talking about safety of silicone bonded facades, and I think we will be actually focusing on seismic performance of silicone bonded facades. And I think earthquakes. This is probably one of the most terrifying event that one can have. One of the most terrifying. One of the usually it will it happens very sudden, and I have my own fair share of experience when it comes to earthquakes, so I should know. Back in 1990, I experienced one of the strongest, if not the strongest, earthquake in the Philippines. It was magnitude 7.7. And it was 45 seconds of just violent shaking, and I will never forget that day. And it was just really a very terrifying event. Many buildings collapsed, bridges destroyed, and unfortunately many fatalities as well. I think some of you, it's in one way or another, being in Indonesia, have experienced it as well. I mean, just looking at these charts here, countries with the most earthquake, Indonesia is at second, and even just the location of Indonesia itself. Looking at all of these dots here, just the number of earthquakes that Indonesia experienced from 1900 to 2019, and looking at the magnitude is just there's just really a lot. So if you look at, let's say, some of the metropolitan areas, LA, Tokyo, Shanghai, Jakarta, these are all, metropolitan areas that are part of seismic regions. And truly in the past few years, in modern times, there has been lesser and lesser building collapse, like major building collapse, especially in the urban areas, right? But still, we have to look at some of the components of the building, not just the main structural components, but also the non-structural components, just like the facades, because they can also have some damage during some earthquakes, just like what you can see in the slide right now, wherein you can have some sort of visibility damage on your facade. You're talking about gasket dislodging. You're talking about maybe glass dislodging as well. You have glass breakage or glass cracking, and sometimes maybe even some glass falling from the facade itself. So these are some of the things that you should be looking at as well, and not just the main components of your facade, or of your building, I'm sorry. Now, if you look at the seismic design of the building, I mean, the weight of a structure that you are designing for seismic is directly proportional to the seismic loading. that it's going to have. Building structures are heavy, and the response is influenced by complex vibrations. And let's just say a lot of the main structures right now are concrete, and concrete is not really a very good material for seismic design. So what you'll do is typically you'll go to technology, you'll go to let's say some dampers to make sure that seismic loads are better managed. Now, if you look at glass facade relatively to the main structure, it is lightweight, and it is influenced by the building's main structure when it comes to seismic loads. The seismic loads you'll have the in-plane loading, and also you'll have the out-of-plane lateral loads. Now, these loads are coming from the P waves from the earthquake, which makes buildings go up and down or shake up and down. And earthquakes will also have their secondary wave or S wave, which makes buildings sway from side to side. So you can just imagine these waves and how they're going to interact with your main structure and how they're going to affect your facade. Now, the main idea about seismic design for buildings is that you should isolate the facade from the main structure. So for example, how would you do that? You'll have you will design your facade joints to be able to accommodate those movements or to allow movements when there's a seismic load. And then also, of course, your connections. You're gonna have some slippage on your connection to ensure that there is that isolation of your facade to the main structure. Now, the other thing, of course, is that you put those theory into test. So it's also very good that you would put or test your facade under those expected maximum movements, so that you'll be able to mitigate those assumed loads that you have regarding seismic. Now we can look at the design codes, and Valerie can talk about the design loads for United States and also for Europe.
Yes, indeed, Gerald. So there are different building codes that can consider seismic action. In the US, we have two such important documents. It's an area-prone to earthquakes. We have the American Society of Civil Engineers standard that calculates the horizontal force on the non-structural component and assesses the glass fallout seismic drift, so the displacement that needs to be larger than a certain limit. Then we have also the AMA, so the American Architectural Manufacturer Association standard, the 501.6. It's an often used testing standard that we use a lot within Dow. It's characterized by the excitation type on the bottom left of your screen. So you see it's a monotonically increasing amplitude, sinusoidal drift cycle, and it determines the serviceability and ultimate drift limit for the glass. The way it's tested is based on a worst case scenario. So you're going in your mock-up to choose the largest glass, the thinnest glass, the most fragile one, the smallest clearances, largest drift index, and so on. And then with this test, you can assess different key design elements of the curtain wall system, such as the SG joints, so the structural glazing joints, the drift, and of course, the primary objective is to determine if we have a glass fallout limit that is within the tolerated value. In Europe, we have the Eurocode 1998, the part 1, that evaluates possible hazard for non-structural elements such as curtain wall. It's a simplified method for a static horizontal force. And then we have the curtain walling standard EN 13830 with Annex D as well. That relates to the seismic resistance, where you can do the testing as well and assess on top of it functionality of the facade in terms of air and water tightness after the seismic event.
Right, and now going more towards Asia, so some of the more popular ones, we have JASS 14, which is from Japan, and this talks about it's for curtain wall itself, and this one talks about levels of deformation on the facade itself, depending on the strength of the earthquake. And then if you look at more locally here in ASEAN, for Indonesia, we have SNI 03-1726, and this is I think the latest version is the 2019 version, and a lot of this loading is based on ASCE 7 as well. Now, we look at the different systems used for glazing. One of them, of course, is captive systems. Now, the more inflexible our facade system is, the more potential it is for damage due to seismic loading. So damage typically happens when there is incompatibility between movements of your building versus to the movement capabilities of your facade. So for example, if you don't have enough joint widths to accommodate those movements, if you do not have enough slippage, as I mentioned a while ago, right, in your brackets, in your facade itself, it's gonna have some, it's gonna cause some problems for your facade. So if you look at, let's just say glass, the glass itself, looking more into that, if you have framing members and you have a system that is rigid, your glass is very prone to touch or from the impact of the framing systems on the edge. And because of that, you may have some glass cracking, or even worse, you may have some glass breakage as well. So if you look at this, all of this loading, so you have your out of plane loading, you have your in plane lateral loads for your facade. And truly one of the, good things about modern times now, there's a lot of buildings that use unitized curtain walls, and unitized curtain walls are very good when it comes to accommodating, of course, provided that they are designed properly. If you look at unitized curtain walls, the P waves of an earthquake, so that movement, that up and down shaking from that earthquake, actually that's taken care of by the stack joint in your unitized curtain walls. Your out of plane loading is taken care of by your rotation in the mullion area, in the brackets of your curtain wall. Now what you're left with is the S wave, which is the side-by-side shaking. Now that is taken care of by your connection to your glass. So it's either you have a captive system, which is what we're showing right now, wherein you only have this aluminum capture taking care of holding the glass in place, or you will have a structurally glazed panel wherein structural sealants are used to stick the glass to the frame. And between these two, the structural glazing will outperform your captive systems. So as Valerie will show on the next slide.
Yeah, indeed, silicone structural glazing or bonding offers you a very interesting movement accommodation capacity that can really contribute to improve the performance of a curtain wall that is exposed to a seismic activity. And that can be related to the structure itself of the silicone. As you can see on the left of the screen, on the bottom left, you have the shape of the polymer, which is really a twisting helicoid. So it already has some flexibility. And then the angle between the bonds, the SIO bonds, is also quite large. And both of these features already contribute at the start to a good movement capacity, and is also a reason why we use successfully silicone for weatherproofing, but also why it will, opposed to other polymers, have a better capacity to accommodate those larger seismic movements. So we have extra flexibility in the glazing parameter. We can reduce the stress concentration in the glazing and really distribute the stress more homogeneously. Another benefit is that our modulus in shear is typically less than in tension. So it means that you are going to accumulate less stress in those shear deformations than in tension, which is also a benefit. On the top right of your screen, you can see the Washington Mutual Tower in Seattle in the US, which was built in 1987. Now, Seattle is not the most favorable climatic condition. There's a lot of rainfall. There's also a lot of temperature swings. And on top of it, combined with heavy winds and also regularly seismic activity. Now, this building, for example, got a seismic event in 2001 of magnitude 7 on the Richter scale. And despite all these adverse conditions, we never got any report of failure of this building that has two-sided structurally glazed insulating glass units.
Yeah, and at the bottom, you'll see this, well, this is a building in Jakarta. You probably are very familiar with this. This is the World Trade Center building and completed in 2017. It's a four-sided structurally glazed curtain wall panel. And this, since 2017, has experienced earthquakes in Jakarta, or at least near Jakarta, that is magnitude 5.0 or higher. And so far, and of course, we're always crossing our fingers that we haven't received any report of let's say silicone damage because of seismic activities for this particular building as well.
Yeah, and so the understanding of the seismic performance of our silicone structurally glazing and our efforts to expand our knowledge date back from quite a long time. So we started evaluating that back in 1996, where we were evaluating small test pieces, H pieces, TA joints, and also did quite some post-seismic building inspection. And based on this early evaluation, we defined a design stress of 0.35 megapascal, 50 PSI, for specific DAO silicones, and also a 25% design strain for some products. To further understand the seismic behavior, we expanded experimental testing in 2012, and that was really related to a real project. You can see in very small characters the reference study that you can consult on the internet. So here again, we combined small scale experimental observation and then larger testing according to the EMAS standards. We have here a four-sided structurally glazed curtain wall unit, and it was a unitized system. Now, unitized system, as Gerald already explained, consists of a system that is normally structurally discontinuous from level to level. It's decoupled from movement in the adjacent floors. But in this project, we decided to look at a worst case scenario. Thus, we assume that the unitized system would not behave as intended in sway, with panels that slide in plane at the horizontal stack joint and keep a rectangular shape, but that there would be some malfunctioning and that we would have a stick-built system with the glazing frame that is continuous over multiple stories, and so that we have a racking under in-plane story drift, meaning also that under this in-plane lateral load at the top of the panel, we are going to see that deformation in the shape of a parallelogram. So logically, this racking is going to transfer larger strains to the structural sealants, but that would show that we have that we would also fulfill in the normal utilization in the sway mode. So here on this video, you can see more details. We have the sway condition, we have the racking condition. The sway was less severe as anticipated. We confirmed that the allowable design limit for movement capacity was good. We only observed damage to the sealant after the glass fallout limit was reached. And for unitized system that would work correctly, we do not anticipate any damage tearing at this target drift. Now, how do we perform any evaluation of a project that needs to comply with seismic performance? We'll start first with dimensioning our joints for wind loading, assuming normal. Can you go back to the
Sorry.
before Gerald? Assuming normal 20 psi or 0.14 megapascal, and then we need to ensure it can take all the deformations that are anticipated for seismic performance. And that is data that we are not calculating. It's provided by our customers. So they will design the facades for the seismic movement, and then we will look at being able to accommodate that movement. Now, on the next slide, we can see how we are further expanding our knowledge today, because you can imagine that this type of large-scale testing mock-ups is time-consuming, it's expensive, it does not allow you to evaluate all the possible configurations. For example, doing a parametric analysis to understand the influence of the joint dimensions, the aspect ratio, and other parameters, it's just impossible. And in the meantime, since 2010, we have seen a lot of progress in terms of finite element analysis and use of this to better understand the limits of our material. We have been using that successfully in other applications. We are looking at cold banding, at bomb blast, and we are also now applying this for seismic performance. So the idea is, again, that we build some small scale experimental test results. We build a hyperelastic accurate material model with the proper meshing. We validate that we can predict what we see experimentally on a small scale, and then we repeat that exercise with one large scale. And once the model is validated, then we can run all the parametric analysis that we want. So what we have seen in the first validation of the large scale here of the EMA test is that we think that the tearing is going to occur when the strain reaches a certain ultimate value in the joint, and that fallout will occur when the tensile or shear stress reaches also a strength limit. This is a preliminary result because we have in this specific case a joint that has an L shape, and this is not the most common. So we are currently building more large-scale experimental tests with a rectangular joint of a few dimensions. We are going to model that, and once this is done, then we'll get to really a full parametric analysis. In the next slide, you can see that we are also keen on collaborating. Gerald, if you can switch, thank you. So we are also working together with Marie Curie individual fellowship research projects, together with leading technical universities in facade and in seismic design. So we have the Dutch University of Delft, and we have the Italian University of the Sapienza in Rome, as well, together with the well-known facade contractor Permestilisa. So it's a project duration of 2 years. It's going to end by July 2023. It's led by Dr. Simona Bianchi, and the project is following a similar approach. So we have a lot of mock-ups that are going to be experimentally assessed, not only on the base of seismic performance, and repeated seismic performance, but also assessing what we mentioned in the beginning of watertightness, airtightness, so really the functionality after a seismic event. And that will then be gradually increased until we reach failure for the different systems. They are going to change details of the system, for example, the stack joint, but also of the joint dimensions. So we have really a maximum of experimental results that will then be modeled with finite element analysis again, so that we understand all the different parameters. And again, there will be, of course, a big attention dedicated to understanding how the damage is occurring in our silicone joint, but also in the elements of the system.
All right. Thanks, Valerie. And now we go to some of the case studies and for seismic performance of some of the real or actual projects that we have. So for example, this building, I think this is very familiar for a lot of us. I haven't been there. I hope to one day. But this is the Apple Park, or the Apple headquarters in Cupertino, California. And we're looking here at the sliding doors. And these sliding doors are, you have 7 meters tall by 28 meters wide doors and a total of 180 tons. And this project or structure being in California, it's very important that these are tests for seismic performance. Now, these doors, as you can see, they're huge and they're really heavy. So it's very difficult to do the test like what's Valerie has shown a while ago. So of course, we can do some FEA, but then they have decided that the team that was doing this have decided that they want to do a mock-up, a smaller version, but still will be able to simulate that movement that the sealant joint will have when they're in the event of a seismic, in the event of an earthquake. So right now, as you can see, we're using here one of our products, 993 structural glazing sealant. It's a 2-part structural glazing sealant. So what they did, you can see there's the glass there. They keep on putting loads there, and then this joint, as you can see, just keeps on deforming, of course, because of that loading. This joint actually is around, I think, double checks 24 by 30, if I'm not mistaken, 24 by 30. That's the dimension of that joint. So as you can see, what happened here was they keep on adding loads to this, of course, to simulate that low seismic loading on this glass and on that joint, and the glass break even before the sealant actually failed or broke. So that, as again, you can see that the sealant was able to accommodate those movements coming from the seismic load based on this particular mock-up. Then we go to, again, another very, I think prominent project, which is the Steve Jobs Theater, also in the same area. So this project, as you may know, right, the concepts that full clarity as much as possible. There's no column, there's no mullion. very lightweight looking. So all you have is this glass and this carbon fiber roof that you have at the top. So they wanted to do a seismic performance test here on that door. So as you can see the swaying from here, and then so you can see how extreme that movement is from that particular video. And in all of this extreme deformations or extreme conditions that you can see here, the sealant was able to handle all of those movement from that swaying. Now, one thing we would like to emphasize here is that here we are showing to you a detail of the glass wall here. And as you can see from here that there's no column, there's no mullion. So everything, you know, the sprinklers, anything that has to usually go in those areas actually went inside this joint here, as you can see from here. So this was, you can see there are 4 layers of glass here. And the idea here is that this was possible. This is not a very usual design. As you can imagine, the key thing here is that during the project, they engage us early. And that engagement allow us to agree on design, to be able to test those design, and to be able to come up with the architect's vision on this particular project. So key thing there is that if you have those designs that are unusual, you can engage with us early, and we'll be happy to discuss, you know, those designs with you.
Yeah, indeed. So I hope this presentation has given you some insights, useful insights in the contribution of silicone structurally glazed facades in seismic performance, and that the way we are behaving is really a big advantage for this application. So as Gerald said, we are really very keen to collaborate for successful facade design. It's really important that you engage whenever you have challenging projects early on, so that we can optimize really the performance of our materials and make sure that our buildings will remain standing tall despite this type of events. So we'd like to thank you for your attention and welcome any questions.
Thank you, Gerald and Valerie. It was a great session to learn so much about the performance of sealant in facades. I think we should move on to the next presentation first, and we'll take questions at the end after all the presentations. So next up is Dr. Huang Chengde. He's the Technical Director of Architectural Glass Division at CSG. With over 16 years in energy-efficient glass for buildings, Dr. Huang has worked on numerous landmark buildings at different locations in the world for glazing solutions and participated in many related Chinese code activities. He is experienced in specifying glass performance to provide proper guidance for energy-efficient design of buildings and in new product development. I'll pass the time over to Dr. Huang, and he's going to answer application consideration of low-E glass products in buildings. Dr. Huang, please.
Yes, good afternoon, everybody. So I'm going to share my screen.
Yep, we can see now.
It's okay?
Yep, it's okay.
Okay. So today I will talk about the application consideration of low-E glass production buildings, especially the energy performance, energy efficiency. When we're doing projects, we always specify glass by the shading coefficient or G values. But when we look at the spectral transmittance of the glass products with the same shading coefficient or G, we see some difference. As you can see on the diagram here, they show 3 glass with the same G or shading coefficient. But the triple silver low-E glass with the maximum visible transmittance and the minimum infrared transmission. With the single silver low-E, you see the maximum infrared transmission and the minimum visible transmission, with the double server somewhere in between. So it means that with the same shading coefficient or G values, but the energy performance, energy efficiency actually is different. But nowadays, everybody is designing air conditioners by G values or shading coefficient. That means if the G value shading coefficient is the same, they treat it as the same energy efficiency. But actually, it's different. The triple server low E is much better than other tools. So SHGC or G values actually has some problems, because the infrared radiation is the energy core temperature increase, but the visible light is daylight we need. In the table here shows 5 products. The first one is the triple server low E. The second one is double server low E, and the third one is single server low E. And the fourth one is the solo plus single server. The fifth one is solo reflective. These 5 glass products are typical glass products in buildings. In the last 70s, the solo reflective glass is used in buildings, and later on in the 80s and 90s, and the solo reflective plus single server low E, and then in the 80s and 90s, the single server low E. So by last century, actually double server low E and triple server low E. The 5 products have the same shading coefficient. As you can see, all of them have a shading coefficient around 0.33. So if we just consider the shading coefficient, it means the energy efficiency probably is the same. Actually, when we look at the visible transmission, you can see the triple server low E has visible transmission about 65. That means you have much more daylight. Well, double server low E has a 48 visible transmission, and the single server low E is 38, and the solo plus single server low E makeup, you have a 28 visible transmission. If they are only the solo reflective, you only get 20% visible light. But you look at the infrared transmission, the solo, you can see that with triple server low E, you get a 3.9 infrared transmission. The double server low E only 9%. The single server low E 18%. The solo plus single server low E, you get about 22% the infrared transmission. The solo reflective, you got 28% of the solo reflective. So you can say actually the energy efficiency with the same shading coefficient, but the actually energy performance is totally different. With the triple server low E, you get more visible light, but the infrared transmission. That means in the room temperature, the temperature is the lowest, it's cool. With triple server low E, you only need 3 small air conditioners. But with the bottom one, like a solo reflective coatings, you have to set up a very big air conditioners. At some time, the visible light is not enough. You have to use the electrical light. So the total energy performance, energy efficiency has a very big difference among the different coatings. So I'm just summarizing here. The same assay does not mean the same energy efficiency. Assay cannot properly tell the performance difference of various glass products, especially with different coatings. Shading coefficient or SHGC may mislead in design of energy efficient buildings. So we need a better term, to characterize energy efficient glass products and to evaluate building energy efficiency. Actually, here in China, we defined the new term called GIR, it just counted how much the infrared light transmitted inside. Like the G values include two parts. The first direct transmission, and the secondary part. The second part is the signal transfer. When you calculate the G values, you start the integral start from 300. Here we just count the infrared transmission, so we start the integral from 780. With the GR, we can quantitatively precisely measure the fraction of incident solar air transmitted by the glass to the interior, because solar air is the energy cause temperature increase, cause temperature rise, in the room. So with the GR, we actually tell the difference of various glass products against the solar infrared, more accurate computation of cooling load. And it's significant in optimizing glazing solutions for energy efficient buildings and in developing new products. In this table here, I just list the GR values of almost every type of glass. From the top is the monolithic float glass, the 6mm no iron glass. You get GR 89%. That means 89% of the infrared light is transmitted inside. Down to the bottom is the low E glass. With the 777 low E, you get only about 3% of the solar infrared light transmitted inside. So with the 777 low E, you get the cooler inside. This diagram shows the transmission spectra of different 777 low E glass, the different colors, different brightness, but they have the same feature. You can see that in the near infrared region, the transmission is very low, only a little. But the visible light could be higher, has different visible transmission as required by different projects. We can just create different coatings to meet the visible light requirement. This table just shows some data. In the right-hand column, you can see that all the 777 glass have a very low infrared transmission, the GR values. That means with all the 777 low E in a room, the temperature is similar. But you can see the shading coefficient could be high, from high to low, from bottom from top to the bottom, and the visible light is high in the top and lower in the bottom. This just different 777 low coatings. It will give you a different look, different color, different brightness. But with any of these glass products, in a room, the temperature is similar because the infrared energy which causes temperature increase is similar. The higher shading coefficient only means the higher visible light transmission, but the visible light does not cause temperature increase directly. So with 777 low E glass products, because all of them have a very low transmission of the solar infrared, so it's only needed to consider, how much visible light you need, how much daylight you need for the building. Now, most of our products are already listed in the IGDP. You can look up the data, optical data in the IGDP, International Glass Database. So with projects, when we consider the glass specifications, we also want to create a bright and cool space, and of course the cost considerations. In this table, I just show some, the performance of the same coating, same triple coating on different substrate. That means the substrate effect. It's very interesting. You can see here. With low iron glass substrate, you get the visible transmission about 69%. And with clear glass, get a slightly lower visible transmittance. If we apply the triple silver coating on tinted glass, you can see that the visible light transmission is lower. And green glass, blue glass, light gray glass, you can see the visible transmittance is lower. If you only look at the shading coefficient, you can see that with low iron glass substrate, the shading coefficient is the highest, about 0.35. So if we only consider shading coefficient, that means the performance is not good, because probably get the more energy. Of course, more energy comes inside. And when you design air conditioners with the shading coefficient, the cooling load is higher. And with the tinted substrate, you get a lower shading coefficient. It looks like probably the performance is better. However, when we look at the GIR, this right-hand column, you can see that the GIR values for low iron substrate is the lowest, only about 2.9%. With the tinted substrate, you get a lower shading coefficient, but actually you get higher GIR values. That means more solar heat comes inside. So the room temperature is higher than the glass with the no iron substrate. So that's a problem. If we only consider shading coefficient, so the coatings on the tinted substrate looks better, but actually the room temperatures get higher because of higher GIR values. So that's a problem. And when in my experience, in many projects, especially in South Asia, I made some projects like a skylight. They told me that they need a very low shading coefficient, for example, like 0.15. And you could achieve 0.15 by meaning by different glass setups, glass makeup. You even could use the solar reflective coatings only to achieve the shading coefficient. But only that with the solar reflective coating, you can get a shading coefficient of 0.5, but the visible light transmitting is lower, but actually GIR value is high. So that's a problem. That's what. So for the room comfortability for the cool, to create a cool room inside, we needed to consider the GR, which tells us how much, really how much the solar heat is coming inside. The solar energy comes inside, cause temperature increase. That's a solar infrared. For example, here, if some projects they need a shading coefficient of 0.22, then we can have different approaches. The first one, we could use the 777 low coatings on low iron glass to achieve a shading coefficient about 0.21. And the second option, we could use 777 low coating on tinted glass. You can say we can also achieve a shading coefficient 0.22. And third option, we could use single silver low coating on tinted glass and gray glass. We can also achieve a shading coefficient 0.22, below 0.22. But the difference is for 777 low coating on no iron glass, we get a visible transmission about 40%, and the GR values about 2.8. That means we can create a bright room, bright and cool, bright room and cool inside, because GR values, the energy, cause temperature increase, only about 2.8% comes inside. For the 777 low on gray glass, you get visible only 23%. But you get a GR values about 10%. That means the daylight is not enough, and room inside is getting higher temperature. The third option, the single silver low on gray glass, you get visible transmission only about 18%, even less daylight, and the GR values are 13%. So you could say that the energy efficiency or in performance, all the performance is totally different, but the shading coefficient is almost the same. So if we design air conditioners, air conditioning system with the shading coefficient, we get some problems. With the shading coefficient, the three options could mean the same, but actually it's different. With the 777 low E, actually you only need small air, only a very small air conditioning. But for the single 777 low E, you could say that the GR value is about 4 times the 777 low E ones. So the energy comes inside, course temperature increase, has a big difference among these three products. To further show the difference, here we just show the cooling load just for the sample building with about 10,000 square meters. Here we just calculate cooling load for 5 different glass makeups. Here the glass show here just have the same look, because when we do projects, we always the selected glass at the very beginning by the appearance, how what kind of colors, how it's bright. You just by the colors by the glass. So here the 5 glass have the almost similar colors and the similar brightness. That means the visible transmittance similar, and the light reflectivity is similar. Here we show that could say that the cooling load. Here the cooling load is calculated by GR values, not by the shading coefficient. The calculation procedures like this. first step, we calculate the cooling load under the same conditions, the same locations, under the same weather conditions, and you evaluate temperatures. With the 3mm standard glass on the window, and then we use GR values to rationalize the cooling load to the glass. Because for 3mm standard glass, we have GR values, and for the glass here, we have the their GR values. So we can use the just rationalize to calculate the cooling load with a simplified method. You can see here with the triple server load, you get about 200 kilowatts of cooling load. With double server load, you go to 300. And the single server load is much higher, close to 500. But the single solar reflective plus single server load double coatings, you get the cooling load about 620. But if you use only a solar reflective coating, you get a cooling load from higher than 900. You can see the cooling load is totally very different. That's a very big difference among the glass products.
Hi, Dr. Huang. We are almost time up. Can you please try to wrap up?
Okay, just and then just show some pictures here. The real pictures of glass. This is a clear one. Just some of the sample projects with several. They just show you how it looks like. So we have different colors, different brightness, the many kind of products for different projects requirement. Yeah, that's all. Thank you.
Thank you. Thank you, Dr. Huang. That was an insightful look on the data of many different low E glass, and in particular, the impressive performance of a triple silver low E. In the interest of time, we will push the question and answer to our discussion round at the end. So I shall introduce our next speaker, Mr. Malvinder Singh Ruprai. Malvinder is working for Kurare as Senior Technical Program Manager. He is a structural engineer by qualification and experience in structural analysis of glass facade, finite element analysis of laminated glass in different applications that include viscoelastic properties of polymeric interlayers. This is his forte. He's provided consultancy support to architects and facade consultants in Asia Pacific region, especially for complex applications of laminated glass like glass resistance, bullet resistance, anti-intrusion, glass pools, and flooring. He's also a member of committee for Indian standards related to safety glass. Malvinder, the floor is yours when you're ready.
Thank you very much, Priyap. Thank you for the nice introduction. Hello, everyone. Very good afternoon, good evening, good morning. For if someone is joining from Europe or Americas, yeah. So let me just share my screen. Is my screen visible or not yet?
No. Okay.
Oh, yes.
Yeah, we see it now.
Okay. I hope my audio is also good. Yeah.
Yeah. Yeah, we can hear you.
Okay, good. So yeah. So today I'm here to talk about advanced interlayers for laminated glass applications. Although laminated glass has been in use in the industry for quite some time, but it's a fact of the matter that all laminated glass, they are not the same, because what goes inside the two layers of the glass can actually influence the structural behavior of the glass to a large extent. So in today's presentation, we will see that how the type of interlayer that has been used in between the two glasses that influences the different performances of laminated glass. Yeah. Okay, so before that, I would like to make a quick introduction of what is Kuraray and what we do. So Kuraray is a Japanese multinational chemical company, but having its footprint all over the globe. So we have 7 manufacturing sites and 2 R&D labs and 18 sale office all over the world. Yeah. And in the advanced interlayers vertical of Kuraray, we manufacture a variety of interlayers for different applications. So starting with the most standard application, which is a safety glass. So we have Trossifol clear and ultra clear. These are the interlayers that we recommend to use for when you just want to make the glass a safety glass. And then we have for decorative, acoustic, structural, and security. And there are some specialized applications as well. I'm pretty sure you are already aware about some of the product names already. But very recently, we have added a new product into our kitty, which is Trossifol Bird Secure or bird friendly glazings. So this is an interlayer which can be used for such applications. And in today's presentation, I will have a special focus on this particular product that we have introduced in our kitty. Yeah. Okay. So moving ahead, I think in the previous presentations, we have seen that how the importance of glass is increasing day by day, and in the past few decades, we can see that there is no building which is not making use of glass, and it's hard to imagine any building these days without the use of glass. Because of its variety of reasons. I mean, we have seen glass has become an integral component of any modern building because of the variety of benefits that you get from the properties of the glass. But it's very important that you select the right type of the glass, unless otherwise, the whole project can actually go for a toss. So why I say so? Just to emphasize on this, I would just like to play a small video over here. I have played this video at previous events as well, but I think it's very important to keep on repeating the message that we want to spread here, because toughened glass or tempered glass, as it is called in different countries, is considered to be safety glass by the country standards, even in my country, India. And so I think it's very clear that if although toughened glass is going to break in small pieces, but if it is falling from a certain height, it has a great amount of potential to injure the people underneath. So you can just imagine if you are just walking besides such a glass railing and glass is raining down onto your head, it can be fatal. Okay. So you may recall this slide, which the previous presenter Nisha Gopal also presented about, that if you change the breakage pattern of the glass, that also helps in achieving the desired degree of safety that you can get from the glass. And of course, in this case, you can see if the fragments are getting smaller, for tempered glass, it is definitely improving the safety, but not necessarily it could be an absolute safety glass. So we can say that laminated safety glass is the most safest type of the glass. But having said that, we must remember that what it goes inside the two glass layers will actually influence the especially the post breakage performance of the glass. And also it's important to highlight that the temperature and the duration of the load will have a big impact on the post breakage strength here. So quite often, these are the two parameters which are not taken into the design considerations I think with the growing awareness that has come up in the recent 2 decades, now it's especially the ASTM 1300 and some of the European standards, they have made provisions for consideration of the temperatures and the durations of the load, because they have a significant impact on the shear modulus value of the interlayer. Yeah. Okay. Then moving on, the different applications where you may have to use laminated glass. These could be safety, structural, acoustic, and bird secure. This is a new introduction into our kitty. And security applications, cyclone resistance, and decorative. Yeah. So in today's talk, I will touch briefly all the applications. I think in the interest of time, maybe we won't be able to go into much details of each application, but I'm definitely available if you have some specific questions related to any of these segments. You can always reach out to me. Yeah. So let's start with the safety first. So this is an extract that I have taken out from the IS 16231 with part 4, which is an Indian standard for the use of glass in buildings. It is related to the human impact on the glass, and also it is a part of the National Building Code of India. Although it's a standard from India, but I think it's very much similar to the other country standards, which make it mandatory that whenever there is a overhead application of the glass, I'm talking about the case number 4. So the application could be skylights or canopies. There it is mandatory to use laminated safety glass. And the case number 5 is when we have glass railings, then the use of laminated safety glass is recommended. If we talk about case 3, the vertical applications, here it's a recommendation to use laminated glass, but it is not mandatory as of now. But in some countries like Singapore, it has become mandatory to use laminated glass when using from a certain height of the building. Yeah. Then for a standard application where the intention is just to make the glass laminated safety glass, so there you can use our Trosifol clear or the ultra clear, depending upon what type of glass you are using. Yeah. Then we talk about structural applications. These are the applications where the glass is acting as a structural element just because of the reason it is minimally supported. It may be supported on point fixings, as you see in the picture for the glass railings, or it could be a glass flooring where people are standing onto the glass surface, and it is supposed to sustain a considerable amount of the live loads to which it is getting exposed. For such applications, we recommend to use our structural interlayers, which are Sentry Glass and Trosifol ES. So I have a video over here. So let's see how it behaves when a PVB laminate is broken. So in this case, you see it's a cantilevered glass which is supported only at one edge, and we break both the glass layers and see its post breakage strength, how it is. And this test is being conducted at room temperature conditions in somewhere close to Berlin, where we have our manufacturing facility in Troisdorf in Germany. So you can see, Europe has a climate which is much more moderate compared to the climate conditions in Asia Pacific region. So we can say the maximum temperature even during summers is not reaching beyond maybe 30 degrees centigrade. So even in those kind of conditions, the PVB laminate is not able to sustain even its own self rate. Yeah. Now I would like to play the video for a Trosifol ES interlayer, which is sandwiched between the two glass layers, the same glass construction but with a different interlayer. It is ES. ES stands for extra stiff or structural PVB, And in this case, you saw we placed these gunny bags on the top of the surface, but even then these were not able, these were not sufficient to bring down the cantilevered piece of glass. Yeah. Okay. Yeah. Okay. So when we talk about structural applications, you may have seen the glass is minimally supported, and when we say that the glass edges, these are exposed to the environment. Because they are minimally supported, and they are not getting framed on all the four edges. So it's very important to ensure that the laminated glass that you're going to use has a very strong durability against ingress of moisture, and when it is exposed to such conditions, it may have a tendency to get delaminated, especially if the interlayer is hygroscopic in nature. So it's important to ensure that the product or the interlayer that you're going to use for such application has gone through the rigorous weathering tests, which are strongly recommended for such applications. So we have natural Florida exposure, which is a test going on for our laminate interlayers like sintered glass for more than 20 years. And also you can simulate such tests in the lab, where you can expose the laminate to temperatures of from -40 to 82 degrees centigrade. Yeah. So although you can simulate the conditions in the lab, but there is a big debate always going on regarding the actual correlation between the test or between the outcome of the test results in the lab versus the performance of the laminate in the in actual use conditions. Yeah. So yeah, so you can when you're using laminated glass for any of your projects, obviously you can't wait for such long durations. So you have to rely on the lab test, and I would say it's a kind of balance that you have to maintain between the two. Yeah. So when we talk about the open edge conditions, it's one of the parameters which is very important to look at for a facade consultant is the ESN number. So ESN number is the edge stability number of the laminate. So how this is calculated, you can see the formula on the top right corner of your screen. So this is a formula for deriving the ESN number. Basically, what it means is like you are giving a higher weightage to any defect which is found in the vision area of the glass, and a less weightage number has been given to any defect which is observed near the edges of the glass. So which means there is some degree of tolerance for any defect which is observed, let's say near the from a distance of 1.6 millimeters from the edge. So that might be acceptable. Depending upon if the glass is getting framed or not. So I would recommend to go for an interlayer, especially when you have exposed edge applications, because there you can't afford to have any kind of defects. Otherwise, I mean, there will be a big compromise between the intent of the architect when he wants to have a seamless view from the glass railings or whatever application it is. And especially if you're making use of an extra clear glass, there in some cases just for the beauty of the edges, extra clear glass is preferred. So you can't really take a chance, and we would recommend to go with an interlayer which has a proven durability against such weathering conditions. So Sentry Glass retains its ESN number of 0 after being exposed to the extreme weathering conditions in Florida, which is known for its high humid and high temperature conditions after more than 20 years now. So this test is still going on, and we do this observation every year. And now I think this 21st year is going on, and I think we will be coming out with the latest data sometime within this year. Yeah. And also here you can see the comparison of the stiff PVB and the Sentry glass and the standard PVB. You can see the standard PVB has its ESN number reaching close to 375 just after 5 years. And also the blue line that you see, it says the ESN number reaches up to 100 just after 5 years. I mean, the ESN number is a very well accepted number in the industry, and it is said that anything below 500 is considered a good number for the durability of the interlayer. But when it comes to open edge applications, I will recommend to go with the ESN number of 0. So you have a clear choice to make between the good, better, and the best. So here I have a quick comparison of standard PVB, structural PVB, and Sentry glass. As you can see, for Sentry glass, it stands completely different, completely stands out from standard PVB and structural PVB on all the parameters mentioned on the left-hand side. Whereas structural PVB, in terms of the post-breakage performance at room temperature and the structural properties at the room temperature, these are quite comparable to Sentry glass. But yeah, it has some limitations, and that is why it is it is classified as in between standard PVB and Sentry glass. Yeah. Then we talk about security applications, and security is becoming a big topic of concern all over the world because of different reasons. So we have sometimes terrorist incidents happening. So where the intention is just to make the occupants of the building, safe whenever there is a potential attack onto the building. It could be vandalism, or it could be an incident of terrorism. So there could be a blast happening outside the building, or there could be some shooting incident happening outside the building. So there are different country standards available for rating the intrusion resistance of a building of a particular glass that is being used for a facade application. So when we are talking about low levels of threat, the test is done as per the EN 356 standard. The test is done by dropping this steel ball, which is weighing 4 kgs, 100 mm in diameter. So that it is dropped repeatedly 3 times in a triangular pattern, and this glazing is given a rating from P1A to P5A. So you just vary the release height of the ball, and if this ball is able to make a penetration into the glazing, it is considered as a failure. And for higher threat levels, we have the threat levels from P6B to P8B, where the test is done with the use of a mechanized X. And so I have a video over here, which is for a test done on a piece of glass, which is required to sustain impacts from different types of weapons that could be used. So in this case, you can see this piece of glass was actually shot by 5 number of bullets, 7.62 mm bullet, and now it is being subjected to like 20 bricks. And now this man is trying to break the glass by kicking the glass using a steel-toed shoes. Now he's trying to break the glass with a hammer. So the intent is to make a penetration into the glass and enter the building, you know. So here the purpose of using this type of glass is to make the intruder, increase the amount of effort and the time that he has to take to make an opening in the glass. So by this time, it is expected that the alarm systems of the building, they will start and give sufficient time to catch that person. Yeah. So now he's trying with a baseball bat. I think that this video is pretty long, so I will just move it quickly to see that what kind of weapons he has used. So in total, it took like more than 12 minutes to completely break the glass, but still it was not sufficient for this person to make a sufficient opening into the glass and enter the other side. Yeah.
Sorry, Malvinder, can you please try to wrap up soon?
Okay. Yeah. Okay. So this is for security glazings. The standard security glazings, they are making use of conventional materials like polycarbonate and the PVB interlayers. They have a very limited durability. The advanced interlayers like Sentry Glass, Spall Shield, they are known to reduce the weight of the glazings by 50%, and they are extremely durable because they can withstand high temperatures. Then moving on to acoustics, here we have a comparison between the standard PVB, standard single monolithic glass, and then we have PVB laminate glass and acoustic PVB laminate glass. So there is a clear difference of 3 decibels from standard PVB to acoustic PVB. And here, then we move on to the Trossiful colors. When you want to play with different colors, we have color interlayers available. 2 unique products that we have in our kitty, they are Trossiful Diamond White and Brilliant Black. These are the 2 interlayers which are 100% opaque. They don't allow any light transmission. I mean, the light transmission is 0 in this case. Yeah. So this is a project which has made use of the diamond white, and to achieve this kind of look, you have to do the ceramic fitting on the glass, but in this case, you see there is no optical distortion because with the use of diamond white, the architects were able to use annealed glass for this application. Yeah. Bird-friendly glazings, I think with the rapid urbanization, our cities are becoming concrete jungles, and they are making use of lots and lots of glass, and it is resulting in not so favorable conditions for the birds because they can't really make a difference between if the glass is too clear, they just collide with the building, thinking that there is a clear passage for them to move. And it is estimated that more than 1 billion birds, they actually get killed because of this just in the US. So the existing solutions, they are making use of this kind of ceramic fritted patterns on the glass. So the downside of this kind of pattern on the glass is you have to do the heat tempering of the glass, and which is a kind of compromise with the appearance of the glass, because you do any kind of heat treatment. First is the optical distortions, no matter how good the damping quality is, but there is some compromise. And at the same time, when you do this kind of ceramic fitting, you are making the glass weaker. Yeah. So we have a solution. We have this dot pattern getting printed on the PVB interlayer, which is available on PVB and Sentry Glass as well. So we do the printing on the interlayer itself, and this can be sandwiched between the 2 interlayers. And we have done all the necessary testing for this. So this is how it looks. So we have a comparison here this is how the glass looks when viewed from a distance of 1 meter. On the left-hand side, we have a standard laminated glass with a PVB interlayer. And when you move further from a distance of 2 meters, it looks something like this. And this is from 3 meters. Yeah. And this product has got the necessary certification from American Bird Conservancy. You can get more details about this product on our website, and you can get the brochures also. So this was all from my side. Any questions and comments? Yeah. Thank you very much.
Thank you, Malvinda. It was a very interesting presentation, and I think we all learned something new today. There's a new bird-friendly glass.
Yeah.
So
thank you.
Thank you all speakers. I really enjoyed every presentation. I'm sure the audience feel the same. Please continue to send us your questions using the chat function. There has been a few questions on the chat, and I will start asking them one by one to the different speakers. First up, I think let's start with Nisha. There's a question from Nagaraj. He's asking, is it possible to make ceramic lamination with coating face inside?
So it's interesting. I was looking at that question earlier. So in the past, I've asked that question and asked whether we could actually laminate effectively the ceramic between two panes. I've avoided it in the past and tended to either go for an interlayer, just because you can't tell what the ceramic's going to do. And I know I've asked in the past, if it's an IGU, then obviously it can sit within the cavity. But then again, you need to check the thermal stress potential with that, and especially for the darker colors, where we found that actually the temperature gets so hot in that unit that it's actually not tenable to work. So I personally find the whole glass industry is fascinating because things change constantly, and a question we may ask one year, the next year they've got a solution. So I think it's really important for us all to keep in touch with the supply chain, constantly ask the questions, because I also think what's so important, I used to speak to, Saint-Gobain, AGC, Guardian, and say, these are the questions we're asking as consultants. Can you solve them for us? So if you ask enough times, they'll find it for you. But no, my own personal, experiences, I've not actually sandwiched ceramic fret between two pieces of glass, but I have used it within IGUs or within shadow boxes.
Yeah. Thanks for the answer. I think I also agree with you. Better be safe. It's a lot of adhesion issues that we need to ask when we start doing that. Okay, next question that is to Dr. Huang. It's from Marcel, and he asked regarding low E combination that Dr. Huang had explained. Will that affect the look and distortion on glass facade?
Okay. So the colors, actually we can create any kind of colors you need for projects with any kind of coatings. Triple silver low E, double silver E, single silver low E. We can have the similar colors, no problem, because we developed many coatings. In China, every big projects they need the individual colors. So almost every day we work on the colors. So any kind of color brightness, we can, no problem for us. We can create. And for the distortions is mainly related to the actually the thickness, the thickness of the glass, especially outer glass, and of course the processing quality in like a tempering, or the heat strengthening, and during the heat up and cooling process, we have to control the quality and as better, as good as possible, to reduce the roller waves or warpage. The roller wave or the warpage is a cause of the distortion. But the main reason, for the distortion on facade, just is depend on the thickness. Actually, the thicker, the better for the glass appearance. So of course, the reflectivity has some, effects. The higher the reflectivity, we could, say, more obviously the distortions. But actually, the coatings, has, especially for the, on the facade, another problem is the stress pattern. After the heat processing, every glass has stress patterns. But if it's obvious or not, by human eyes, it's depends on the coatings. So the coatings has some, effect on the stress patterns. Some coatings obvious, some others is better. So actually, for the any kind of colors, any kind of coatings, we can, because we do projects all over the world in different locations in the huge projects. So for us, there's no problems. But the only nice, especially for the stress pattern, you have to more careful that because in the different locations, the background light is different. So if it's obvious or not, it depends on background light. So when you do huge projects, it's better to install the markup samples on the project side to evaluate if it's the stress pattern is okay or not. For distortion of problem, distortion just if the glass is thick enough and the quality control is good enough, there's no problems. Okay, is that okay for the answers?
Yes, I think that was a good answer. Thank you, Dr. Huang. Indeed, yeah, I also agree. Most of the time is the roller waves causing the distortion. Thank you. I shall have another question for for Malvinder. So Justinus, he asked, is there any PVB for Lamy glass for building use to cut infrared, similar to IR cut for Lamy glass?
Well, I think this is largely done by making use of a performing glass. The coatings are actually more helpful to achieve this function. So currently there is no technology which can actually make the interlayers cut the IR radiations. Yeah.
Okay. Yeah, okay, thanks. I hope that answers your question. It was also a very interesting question also for me. If there is, I also like to get one. The next question is from Veronica, also to Malvinder. She's asking that we are doing escalator enclosures instead of using laminated glass. Is it possible to use monolithic glass with safety film that goes into the back of the frame? So that means the film goes into the back of the frame as well.
Sorry, your voice is too low. Could you repeat your question?
Oh, sorry. I'll say again. So
yeah.
Veronica asked that for escalator enclosures, instead of using laminated glass, is it okay to use monolithic glass with safety film that goes into the back of the frame?
If you use some type of, I guess when she says the film, it is a kind of polyester film which is applied onto the glass surface. Am I right?
Yeah, presumably is some safety film. Yeah, one of those safety films in the market.
Yeah, so such kind of films, these are generally applied onto the glass surface as a retrofit measure. I have seen such films being used by the developers whenever some safety incident happens, and after that they adopt this the cheapest way to make the glass safer, but actually you can end up making the glass more unsafe, because what happens in this case, if there is a breakage of the glass there, with an impact, the entire piece of glass can actually come down falling. So compared to the case when you have just a monolithic glass, a fully tempered glass. So there, you will have small clusters of glass falling down. But in this case, when you're applying the film, the entire piece will actually fall on somebody's head. Yeah. And another thing is, I have seen that kind of films being used in many places. The durability of those films is a big question mark. And over a period of time, they have a tendency to come off the glass surface, especially from the corners. These are actually no match to a laminated glass. Yeah.
Yeah. Thanks. Thanks, Movinder. And I think there's one more point, that is, if it's laminated glass, there's two pieces. So one breaks, the other one still standing, right? So that's still one other thing. Okay, one more question that's from Marcel. He's asking, what's the total thickness of Sentry bulletproof glass?
Well, it depends on what type of bullet you are trying to stop. I can, in my presentation, I mentioned that with the advanced interlayers like Sentry glass and Spall shield, you can actually make the glass constructions lighter by 15 to 20%. I can just say, like for BR6 threat level, as per the EN 1063 standard, the bullet construction that is required to stop that bullet is just 37.9 mm thick, compared to the 70 mm thick glass construction that is required for when you have standard conventional materials like polycarbonate, and you're trying to achieve the no Spall solution. So no Spall solution is achieved by different methods. One of the methods which is very aggressively promoted by glass companies is like they are promoting more glass on the protected sides, because glass is cheaper compared to any other like polymeric interlayers like the PET film that we use. But if you use that solution, you end up having a big bulky glass construction which is 70 mm thick. Yeah. So one of the glass companies, I won't name, so they are promoting 70 mm thick BRG construction for BR6 level. So compared to that, our solution is just 37.9 mm thick. Yeah.
Thank you. Thank you, Movinder. I hope that answers your question. I think there's one more question for Jero and Valerie from Takashi Kawaguchi. His question is quite technical. It says, what's the gutter splicer design at head section between curtain wall panel units for previous tests in laboratory? According to the movie of stack joint behavior, the gutter splicer is splitted type. If we adopt continuous gutter splicer between curtain wall panels, what's the major difference of panel behavior and structure sealant behavior to seismic load compared to splitter gutter splicer? Got that?
Yeah,
Okay.
really technical. Can you just repeat, because it does a long question? I agree.
Yeah, should I repeat it?
Yeah, can you kindly, sorry, just so that we don't miss anything.
Yeah, okay, so he says, what's the gutter splicer design at the head section between the curtain wall panel for the test? And according to the movie, the gutter splicer is the splitted type. So if we use the continuous gutter splicer, what is the major difference of the panel behavior and structure sealant behavior to seismic load when compared to the splitted type?
Right, I think if I understood it correctly, so it's talking about, so on your gutter splices and your stack joints, right? There will be some gutter splices, and the assumption is that on that presentation, I think Valerie, the one that we showed on that movement, is that it was just a split splice, or basically something like that, and that versus wherein it's continuous. I think this is the question, right?
Yes, I think so too.
All right. Yeah.
There are actually quite some details on the exact setup in the paper that is referenced on the slide and that we can share later on. So you will see all the measurements, exactly how it was done.
Yeah, I think the answers, the best will be just to we will share that paper where we can have a more detailed answer to that question. They can they can see the setup on all of those movies that we showed a while ago.
Yeah. Thank you. Yeah, that's very good. That's very nice of you to share the paper. And I think with the paper, you should shed a lot of light on how it's done. Yeah, appreciate that. I think that's all. Don't see any more questions from anyone. So I think that's all from the audience. So I think so we have now come to the end of this webinar. Thank you everyone for your participation. We'd like to say a big thank you to CSG and Kurare for your sponsorship, and to our distinguished speakers for your insightful and informative presentations. Please do remember to save the date 26 to 28 of October for Glasstech Asia and Fenestration Asia Exhibition and Conference. Again, this exhibition will be held in Singapore at Sands Expo and Convention Center. To know more, please check on the website, which is www.glasstechasia.com.sg, or you can follow them on social media by scanning the QR codes on screen. Last but not least, you will be directed to complete a feedback form after you leave this webinar. Please complete them to help us improve. It is a great pleasure to be your moderator and host. Till next time, please take care and stay safe. Thank you.
Thank you.
Bye.
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 谢谢博士。
不是，你的我都听懂了。
啊。
What attracts the attention of the world? What tops the prosperous peak? Who leads the trend of energy-saving building glass? China Southern Glass Holding Group Company Limited. Founded in 1984, CSG became the first listed company in the industry in 1992. From the first introduction of foreign advanced technologies to the possession of internationally leading R&D level, from a leader of the industry in China to a global famous brand. With over 30 years of persistent pursuit, CSG has set up many milestones in China's building glass industry. With more than 20 subsidiaries and 5 top building glass production bases in China, CSG has established a complete production chain of quartz mining, float glass production, low-E energy-saving glass processing, and its capacity tops the world. CSG is leading the new trend of building glass in China and even in the world. People turn sites to high-rise buildings due to the high-speed global economic development, urban population explosion, and land scarcity. Glass as the essential material of high-rise buildings, its safety and energy efficiency have been focused on by society. As the industry leader, CSG has been continuously developing a series of safer, more energy efficient, more comfortable, and more beautiful products with its strong R&D capability, which widely meets the fast-growing building demands. CSG now has 14 of the world's most advanced glass coating lines, with an annual low-E glass capacity of more than 50 million square meters. It launched single silver and double silver low-E glass production in 1997 and 1998, and developed triple silver low-E glass in 2007. The triple silver low-E glass started to be applied on overseas projects in 2009. And CSG is the first China company publicly releasing technical data of triple silver glass products in the world in 2010. The low-E glass products of CSG are featured by outstanding performance and aesthetic effect. The triple silver low-E glass can screen more than 97% solar infrared radiation, which most effectively reduces the cooling load of air conditioning system, cuts the investment of air conditioning equipment, reduces building operational cost, and improves the indoor comfortness. Relying on independent R&D, CSG achieves technical breakthrough. Successfully and firstly in the world, developed various triple silver low-E glass series of a rainbow of colors and brightness to meet the requirement of various building design concepts and styles, and the products have been widely used in numerous landmark buildings in the world. To meet the growing demand of building glass market, CSG, equipped with the most sufficient coating lines, insulation glass production lines, laminated glass production lines, heat soak furnaces, and a complete set of cutting, edging, tempering, and ceramic fret equipment, as well as special jumbo size glass processing and bending machinery. Besides, as the industry leader, CSG has developed a variety of new products to meet the potential demand of customers. Interior surface low-E coating, anti-reflective glass, electrically heated glass, micro insulation glass, counterfoil glass, mirror display glass. In addition to the products, CSG also provides perfect and comprehensive services with the technical support of senior industry experts, worldwide direct sales network, strong storage capacity and logistics transportation. CSG provides whole process tracing and sincere project services. Buildings like solidified poems and vivid paintings, turning buildings into art to show city classics, decorate the world, and realize harmonious development of building and city with our products. Energy efficient and comfort, we make quality goods. With safety and beauty, we set up a leading brand. Pilot of energy-saving building glass, CSG Holding Company Limited.